Hello friends, this is lesson 9, and before you get started you're going to need to draw two rectangles like you see on my screen. And really what we'll do is we'll kind of talk about it, and then I'll give you time to draw it, and then I'll come back and you can continue the lesson. But basically you have to draw and label the side lengths of the two rectangles. So count with me. This measurement over here is 1, 2, 3, 4, 5. Okay, and we'll just call those units. And now the top is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. And the same thing here, 1, 2, 3, 4, 5 units, and this is also 10 units. So instead of cutting that out, we're just going to draw them on our paper. Okay, and as you're drawing that, I want you to know that we call this the length. You might have heard that before. And this is the width. So the area, we're multiplying length times width. All right, so I'm going to stop the recording and give you time to draw this. And when you're done, come on back. Okay, so we've drawn and labeled the sides of the two rectangles. So let's go to letter B. Write an equation to find the area of one of the rectangles. All right, so the area is equal to 5 times 10. So the area equals 50 square units. Write an equation to show the total area of the two rectangles. Well, what do we know? If we know this one is 50 and this has the same measurements, can't we just add those two together? So we have area equals 50 plus 50, which equals 100 square units. Or we could have said area equals two groups, 50 in each group, which equals 100. Either way, this would be the more advanced third grade way. Either way gets it done. Okay, so now it says place your two equal rectangles side by side to create a new longer rectangle. Draw an area model to show the new rectangle. Label the side lengths. So in other words, if we smush these two together, what's it going to look like? Well, let's draw it. It's still going to have 5 down the side, right? But this 10 and this 10 don't have a space in between, do they? So we have one really long rectangle. Okay, so this is going to be 10 units, and this is 10 units. Okay, if you go back to that picture up here, here's the 5. We don't have to do 5 plus 5 because we're still talking about 5 rows across the whole thing. But we have 10 here and 10 more here, so we have to show both of those as our length. All right, so find the total area of the longer rectangle. So we can do that a couple ways. So the area is going to be 5 times this top length, which is 10 plus 10, or 20. Okay, and I know that I can multiply 5 times 2 to get 10 and put that lovely little 0 on at the end, so 100 square units. And that should be the same as we got up here, right? Because it's the same rectangle, we just took that space out in between. Or we could say the area is equal to 5 times 10 plus 5 times 10, which equals 50 plus 50, which equals 100. Either way. Okay, that's problem number 2, smushing it together. All right, let's go to the next problem. Number 3, Faith and Raymond use square tiles to make the rectangles shown below. Label the side lengths on the rectangles above and find the area of each rectangle. Okay, it's a bunch of counting right now. 1, 2, 3, 4. This is 4 units. And 1, 2, 3, 4, 5, 6 units. And we've got 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6, 7 units. So for Faith, we have 4 times 6, which is 24 square units. And Raymond is 4 times 7, or 28 square units. Okay, just length times width again. Faith pushed her rectangle next to Raymond's rectangle to form a new, longer rectangle. So just like what we did from number 1 to number 2 on the other side. Draw an area model to show the new rectangle. Label the side lengths. Okay, so imagine squishing these together. So I've got still 4 on this side, right? But I have a longer section here. One of them is 6 units, the other is 7 units. Okay, I just got those from here and here. Okay, we don't have to find the area, right? It just says draw an area model to show the new rectangle, label the side lengths. Raymond says the area of the new longer rectangle is 52 square units. Is he right? What do you think? And let's figure it out. Area of this rectangle is 4 times 6 plus this rectangle is 4 times 7. So 24 plus 28. What do we get? 20 and 20 is 40, or an 8 is 12, so 40 plus 12 is 52. Yeah. And that's what we get when we add those two together. So we have to explain it. When we add the areas of the two small rectangles, we get 52 square units. And that's what we were doing right here. All right, let's do the last one. Kira says she can find the area of the long rectangle below by adding the areas of rectangles A and B. Is she right? Why or why not? Okay, so rectangle B is this dotted line. Okay, and rectangle A is this yellow part. Is that going to work? Think about what we did up here and over here. You see the difference? Hopefully you see that this overlapping part right here messes up everything. Can't solve it like we did before. So Kira is wrong because we can't have overlapping rectangles. They have to be separate or not overlapping. Okay, so if this overlapping section here wasn't there, we could add the two areas together. All right, so that's it for lesson 9. Go ahead and get your homework going.